And I'll be talking about the work that I've been doing here, looking mainly at this potential spread. So this last talk was a wonderful introduction to what I'm going to talk about. And mainly what I do is I'm a modeler, and what my co-author is Stefan Munsami, who was here yesterday. But what I've been doing for the past decade or so has been working with a group of ecologists and economists to look at a bioeconomic framework for the spread of invasive species. And a shameless plug, we put out a book about 4 or 5 years ago called The Bioeconomics of Invasive Species. I'm co-author on a number of the chapters in that book. And the idea that we're trying to get at is more about prevention and prediction. And so the focus of this book is basically two objectives. Is how can we provide estimates of the regional economic impact invasive species will potentially inflict. So yesterday we had a lot of conversation about what are the current impacts. We're trying to look at predictions. What are things going to impact? And then once we do that, then maybe hopefully we can provide policymakers with quantitative guidance about control, prevention, slowing the spread of invasive species, and so forth. So this book kind of goes through how we achieve those objectives. And to do that, we kind of have a number of steps that we need to know about to achieve those objectives. First, we need to know where things can live, how they can live there, what's the potential regional impact, what are those consequences as they spread through space, and that's only to get to objective 1. And then to get to this actually providing some guidance, we need to know whether prevention and control strategies are effective. We talked a lot about this yesterday, about whether we can actually eradicate things. And then we try and integrate all those things to come up with an answer. I'm not going to talk about all that today. I'm going to talk about this piece, the spread piece. So all these little different things had an outline. So I'm going to talk about the spread of Pernivertis, and I know there's going to be a talk tomorrow called, I think, The Anatomy of the Pernivertis Invasion. And so I'm not going to talk a whole lot about the actual mussel. I'm going to talk about the patterns of where they are in the Caribbean and see if we can model that in hopes that we can use that as a surrogate to potentially model things in the future. So here's where Pernivertis showed up in Trinidad in 1990 and then spread up and down the coast. And then, lovely. So this is one of these things. So I'm a modeler. I don't actually always see the things I've actually worked on. So this is like the closest I've gotten to a green mussel. Especially if I was probably in Caroni Swamp, I probably rode right over one, but I didn't see it. So beauty of being a modeler is I don't necessarily need to get muddy to do my job. And then through the 90s, they spread to Venezuela, Jamaica, and Florida. And then now they are in where these black dots are. So Trinidad, the northern coast of Venezuela, Jamaica, a couple populations in Cuba, and Florida, and around the coast a little bit. So my question when I came here is, can I recreate this pattern based on shipping and potentially current? So I'll talk about two models I've created. One is shipping model and a current model. So the shipping model, I got my data from, I have the acronym spelled out in my acknowledgement, so I don't remember what all that is. But they have data for, I think, for 2007 and 2008, all the shipping traffic within the Caribbean. And so it looks like these, blue lines. So you got heavy traffic going through Panama. I love the phrase heavy traffic now. All you Trinidadians, if you listen to the morning radio, they do the road report. Baratario, heavy traffic. Port of Spain, complete standstill. And so we got heavy traffic going through here, Panama. We have heavy traffic from Trinidad going up into Florida. We have heavy traffic going, there's a lot of traffic in the Caribbean. So the question is, can we model that and can we make predictions about where things are going to go? So since I wanted to focus on Pernivertis, right, so we have Trinidad and Tobago here, and the question is, where are ships going from here and where are they potentially taking things? And in this case, Pernivertis, or the green mussel. So I created a fairly simple model, network model, and for each step of the model, all the ships in this network would leave Trinidad and Tobago, go to a destination, and I would have a probability that they would drop off Pernivertis and a population would start. If a population would start there, then that population in the next time step could send things elsewhere. So if all of a sudden Dominican Republic became invaded, they would be a source as well. So I did this for several thousand times, and each time I did it for like a 20-year trial to look and to see what locations are likely to become invaded with Pernivertis. And so here is my map of relative risk. So obviously, Trinidad, where things are, that's most likely where they are to be in the future. But some other things, Barbados picked up, Florida popped up, Houston, New Orleans, Panama Canal, Jamaica, Dominican Republic. Some things that have green mussel now, and some things that don't. And so we can look at this in table form. I'm not going to spend a whole lot of time here, but so I think I ran this 1,000 times, and 70% of the time my model predicted that Houston would get an introduction of Pernivertis. Well, Houston doesn't have it. Well, why? Well, the Houston port is actually upriver a little bit, so there's fresh water there, so it may not be able to establish. What about Barbados? Barbados was the third highest prediction for me. Barbados has not reported green mussel there. Really good, interesting question about why. I don't know a whole lot about Barbados. I haven't been there. But what about green mussel would restrict it from living there? And so some of these are the questions about whether my model is just bunk. Do I have a bad model? So the first rule of models, all models are wrong, but hopefully they're useful, right? So hopefully this will be useful. Barbados might want to think about why they have not had green mussel. And maybe because their port system is just not a good place for green mussel. Maybe green mussel are there, and maybe just in really low populations. It's hard to find things. Maybe they're not looking. Maybe you need mangrove. I mean, the west coast of Trinidad has a lot of mangrove, nice, good habitat for where things can live. So those are the kind of questions that this model can start asking. So to look at this in a little more friendly version, so these are the top 20 ports that my models predict to have green mussel show up. And as we can see, a few of these, 4 of them, green mussel is actually there. So 4 out of 20, I don't know whether that's good or not. But then we can start to look at things a little bit more. Most of these ones in the US, most of these ports here that are really active with Trinidad, they're upriver some. So they're not really true saline ports. They're brackish, or some are even freshwater. So they may not be the best place for something like green mussel. So at this point, without further knowing more about green mussel or knowing more about these ports, that's my best explanation. But then we have, quite a few locations that my model predicts have a pretty good chance of having green mussel, but they don't. Now, I think we'll probably learn more about the green mussel tomorrow, and that the populations in Trinidad aren't near what they were 15 years ago or 10 years ago. And so the model I built was built under the presumption of that green mussels are at all the ports in Trinidad, and that's where everything's going from. That may not be the case anymore. The populations here are really small now. They used to be really big. And so maybe my model really was only good for 2 years. So these are the kind of things that I'm trying to sort out now. But now I have a model. It predicts some of these places, Jamaica and Florida and so forth. And so it has some validity, but still a lot of questions. All right, so that's the shipping model. So the other thing that can happen, obviously these things live in the water, so the water can move them around, right? So was Pernivertis moved around? By currents, right? So this is the general pattern of currents through the Caribbean. Here's Trinidad down here again, and people have data on how the currents move. So I was able to get data from NOAA on how currents move, and so this is a prediction, an annual average of the easterly movement. So the dark blue means if you are there, you're likely to move east. If you're in brown, you're likely to move west. And then we have Also predictions for north or south. If you're in the green here, you're likely to move north. If you're in the purple, you're likely to move south. Okay, so now I have data about where things are likely to get moved around. And so what I was able to do was to create what's called an agent-based model. There's a nice free software that's fairly simple to use. It's called NetLogo, where you can, the basic premise of NetLogo is it's got two characteristics to work with. It's got, and in their lingo, well, I would call them agents, they call them turtles and patches, right? And so you got turtles moving around some kind of landscape. Well, my landscape is the Caribbean Sea and surrounding areas, and my agents are, in this case, floating pernivertis larvae or juveniles, what have you. So, and then for each patch in here, what I had is how often or what direction they should be moving north and what direction they should be moving east. And then along with these maps here that I had before, so they have predictions or annual averages of how northerly you move if you're in this location. They also have data on the variance around that. So basically, my patches in this area had 4 pieces of information: how far east you're likely to move, or west, how north or south you're likely to move, and then the variance on those 2 directions. So each of my patches had each of those. So it's a stochastic model. And so what I did is see this brighter white dot, is I was able to release as many turtles or this green mussels from Trinidad to see where they go. Now, obviously, with a little technology problems, I was going to have a video so you could actually see this go through space. They would leave here, and but it didn't work with the translation from computers. So, but this is the result. So I released 1,000 turtles, and this is their pathways. All right. So how does that match up with where we have green mussel today? There's a couple places where we have green mussel that this kind of fits with. All right, we have the northeast coast of Venezuela and Florida. Okay. But we also, my shipping model also predicted this location. So now, but we have 2 possible ways that they could have gotten there. But we have a lot of trajectory about locations where green mussel is not. It's not all the way along the coast of Venezuela, at least it hasn't been reported. This is, again, one of the problems with invasive species, especially ones that are aquatic. Somebody's got to look for it and somebody's got to find it. And the other areas, Cancun, I haven't been to Cancun, I hear it's nice. But it's, I think there's probably a lot of beachfront there, and maybe not even, so, green mussel might have been brought here, but it may not be able to get established. But according to my model, there's a lot of trajectory that things from this region should be showing up here. Again, has anybody looked? Has anybody reported it? Or is it, do these green mussels, would they not be able to last that long in the water column? So now the question is, which of my models is more conducive to that spread? We have 2 different vectors. We have a shipping vector, and we have a current vector. So we have models that we can start to ask these questions. The question then is the impact. So this is a biofouling. So green mussel is an organism that attaches to things and gums up things like desalinization plants. So there's also power plants, but my guess is desalinization plants is probably the biggest economic impact for a lot of these biofouling organisms. And I was able to get the locations for about 100 of the 300 desalinization plants in the Caribbean, and this is where they're spread out. So there's 200 more in this region. So a lot of desalinization plants in the Caribbean. There's also 300 plants in Mexico, 2,500 plants in the United States. So there's a lot of this, and I think it's a growing industry. There is an organization called desaldata.com. That's where I got this. I was able to get a 1-week trial membership, and that's how I spent a lot of time getting 100 points, didn't get all 300, and then they shut me down. So that's the question that I'm trying to ask. So we can predict or potentially predict where green mussel can go. We have potential places where it could impact. I've been trying to dig around and actually what is the cost? How much are these desalination plants spending on cleaning their trash racks and cleaning biofouling organisms? They already have some biofouling organisms, but what if something new or something bigger shows up? How much more will they have to spend? That data just isn't out there, or it hasn't been reported in the literature that I can access. So, you know, it begs the question then, what is it worth to slow or stop this spread? So in conclusion, right, we have both anthropogenic and natural vectors of spread. They both seem to be important for the spread of AIS in the Caribbean. These vectors can be modeled. The models are wrong. I'm the first one to admit that, but they can give us some idea of where to think and look. We have lots of impacts, both into biodiversity and industry, and more future invasions will occur. And this is why I've been using something that's already spread, is to try and, you know, parameterize those models so that when something new shows up, we can make predictions of where to look next. With the underlying question is, what is the value of slowing or stopping these future introductions? That's what I like to think about. I would love to talk to the people in this room about it. And that's what I enjoy doing. So with that, my acknowledgments, my funding for being here is a Fulbright Scholar Program. Data and logistics, thanks for the West Indies, University of West Indies for housing me. Data from desaldata.com, the marine traffic, and NOAA for the current data. And with that, just about out of time.